And the sustainability is in every area of our life, including no poverty, zero hunger, and you can see all those 17 goals. And were created in 2016 to help countries measure progress against the objectives in 17 areas. The last thing I want to talk about sustainability is ecological resilience. Our textbook used New York City as one example. After the superstorm Sandy in 2012, the city developed a coastal resilience plan to preserve its shorelines. So I think it's very inspiring to the city like Houston. And here I want you to know what is ecological resilience, which is a measure of how well a system recovers after disruption occurs. So a healthy environment is supposed to have the recovery capacity. Like we humans, we get sick, we have injury, but we were able to recover ourselves. The same thing with the environment. As we humans living in an area like Houston with frequent flooding, and we should learn the story about New York City and see how they build their coastlines to build up their ecological resilience. The next topic I'm going to touch is science and scientific methods. What is science? Science is our way of inquiry. We ask questions and we are seeking the answers to the questions. So the science is a method of inquiry summarized as an ongoing process that uses steps of the scientific method. And we need to use science to understand ecosystems in order to develop sustainable goals. So this is a typical flow chart, the process of a science inquiry. First, we observe a problem. It's always a problem. So we see something, okay? And we make a guess. We ask us questions. For example, we see a pond with the agricultural runoff, okay? And we start to see the frogs have mutations. They probably have 5 legs. Okay, we'll have 2 heads. So we see a problem. It's the abnormal development of the frogs in the pond. So we ask ourselves, what's wrong with those frogs? Why it cause the frogs? What is causing the frogs to be abnormal? So we ask questions, we try to answer our questions. So we make a guess. Okay, some people say it must be the acid rain. That is one hypothesis. Okay, one person may say, hey, this is heavily polluted atmosphere area. And we have factories there have those smokestacks, and so the air is super dirty, and we have acid rain that cause the frogs to have 5 legs. That is one hypothesis. Another person may say, hey, I saw this runoff, the agricultural runoff. Probably we use too much pesticides or fertilizers. I think those chemicals flow into the pond cause the frogs to have 5 legs. That is another hypothesis. Hypothesis is a guess. It's a guess to the answers. So then you conduct experiments and gather data, right? So how do you conduct the experiments? What is a control group? Control group, in this case, we put 10 frogs, okay, in a pond with natural water without any pollution. And the other pond is the pond you observe the frogs with the 5 legs. So the one that in the natural pond without the runoff, that is a control group. If you want to test the air, the hypothesis is the air is heavily polluted. Then you have to have a pond. In the area, there's no air pollution. So that group of frogs is called control group. That's called control experiment. And then after 1 year or 2 years, you keep observing and you record the numbers of the frogs have abnormal developments like 2 heads or 5 legs. And then you pull all the data together, you evaluate the data. It either support or reject your hypothesis. For example, you calculate the control group, okay? It's a natural pond without pollution. And the 5-leg frogs are, let's say, 5 out of 20, okay? And then you count the frogs in the polluted pond. It is 10 out of 20. And you think the difference between 5 and 10 out of 20 is significant. Then you conclude your hypothesis is right. You said, hey, this is my data, it supports my hypothesis. If your control group is 5 and your experiment group is 3, then it does not really support your findings, right? So you can say, my hypothesis is not right. I do not think it's the chemicals in the water cause the 5-leg frogs. So it's something like that. So eventually you evaluate your data, refine, alter, expand, or reject hypothesis. If it is right, you can go peer review and publish your results. If it's wrong, and you will formulate another hypothesis and go through this cycle again to see if your guess is the right answer. So this is a short summary of how science works, okay? Observation is using senses or extension of senses to record an event. So senses to human is the sight, the smell, the taste, the hearing, right? And we have very sophisticated scientific instruments nowadays that can record the temperature for us, right? Record the pH, record the salt content of the water. And so that is called observation. Usually when we say observe, we mean we see something. But in scientific research, observation is using senses or extension of senses to record event. Hypothesis is a proposed answer to a scientific question which can be repetitively tested. True data is a must for science, so the moral standards for scientists should be very high, okay? Because people believe your story, they believe your data. So the true data is truly valuable, even it does not support your hypothesis. That is still true data, okay? And one way to set up observations to test the alternative explanation is the use of controlled experiment, which I just explained to you. So, because this is my test point, you can read the test book and practice coral reef bleaching. Okay, coral reef, the coral and algae, they exist in symbiotic relationship. Okay, the algae gives the coral all sorts of brilliant colors. When the environment changes, such as the ocean gets warmer or it becomes more acidic, the algae get stressed out. So they leave the coral become white and dead. If we do not restore them, eventually become dead. So that is a very good exercise for you to exercise your understanding of control experiment and hypothesis. Okay, so this is in our chapter 1 test book, and you should be able to understand which part is hypothesis, what is the experiments they have done, and if the data support or reject their hypothesis.